Okay guys, so today we're going to talk about graphing linear equations in the form of y equals mx plus b. Okay, so first we're going to look at the equation y equals mx plus b. If you remember, we talked in class that m stood for slope, b stood for the y-intercept, and x and y stands for any coordinate point or pair on that line. Now remember that lines are infinite, so there are many different points on that line. We're just going to look at a couple in order to graph those today. So we're going to look at the equation y equals 2x. So for right now, we've been plugging in points. So we're going to plug in negative 2, negative 1, 0, 1, and 2 into this equation and see what y value that we get. Remember that we talked about x being the input and y being the output, or x being the independent variable and y being the dependent variable. So when I plug these in, I'm going to say, or substitute these in, I should say, I'm going to say 2 times negative 2, 2 times negative 1, 2 times 0, 2 times 1, and 2 times 2. That's going to get me 4, negative 2, 0, and 2, 0, 2, and 4. So as ordered pairs, we would write this as negative 2, 4, negative 4, negative 1, negative 2, 0, 0, 1, 2, and 2, 4. Okay, so this is what you've done in the past, and you've plotted these points onto a coordinate grid, and we're going to do that. So here's the equation again. So you had 2x, and the values that you substituted in were negative 2, negative 1, 0, 1, and 2. And you got negative 4, negative 2, 0, 2, and 4, and made these coordinate points. So now we're going to plot these points on the grid, and here they are. And I'm going to label these just so that we know which ones we're talking about. The grid was too small for me to go in and write all the numbers. So we know that where they cross is the origin. And so the first dot at the lower left corner would be negative 2, negative 4, negative 1, negative 2, 0, 0, 1, 2, and 2, 4. So we can see that these are a straight line, and they're supposed to be because this equation is in the form of y equals mx plus b. If you were to do this and your dots or your points were not in a straight line, you would know that you had done something incorrectly, and we would need to go figure your math again. So, but these are in a straight line, and we're going to connect those. Okay? So now, what I want us to look at is the pattern between the coordinate points you picked, the equation, and the graph, because they all work together. Remember we talked about in class how the equation drives everything. So we know that slope is the change in y over the change in x. And the triangle is delta, and it indicates change. You'll see that in math. So if we look at the change in y over here on the left side, we see that the y is changing 2 each time. It's going up 2 each time, from negative 4 to negative 2. And we can see that the x is going up 1 every time. So we could say that the change in y is 2 and the change in x is 1, and we'd write that as 2 over 1, which we understand is just 2. Okay? So if we go down here on the graph where the triangle is drawn, you can see that I had to go up 1 and over 2, up 2 and over 1, kind of like a stair step. So up 2 over 1, up 2 over 1, in between each point. So we call this rise over run. Okay? So up 2 and over 1 is the pattern between the dots, or the points. So you can see here that between any 2 points, it doesn't have to be the first and second one. I can go for the first and third one, which is negative 2 and negative 4 to 0, 0. Well, from negative 4 to 0 is 4, and from negative 2 to 0 is 2. So 4 over 2, which again will reduce to 2 over 1. You have the same slope. I could choose the first and the last point plotted, which would be 2, 4 and negative 2, 4. Well, you can see here that 4 to negative 4 is negative 8. And 2 to negative 2 is negative 4. Negative 8 over negative 4, again, is 2 over 1. Any 2 points that I choose, you can see this in the similar triangles here listed right in the middle, I'm going to get 2. I'm going to get that slope that's in front of the x, in. Okay? So now, what about the y-intercept? You can see in the equation that there's not one listed. So when we rewrite this, we could actually write plus 0 and see that the y-intercept here it hits the y-axis at 0. That was already listed in our point as 0, 0. We could see the y-intercept there in the coordinate points. Okay. So let's look at a different equation. Y equals 1/2 x plus 2. So again, we're going to pick points. Now, the reason that I've picked these numbers is that they're even. And see, I'm going to have to take half of x. So it's easy to pick numbers that I can take half of because I get a choice. I'm going to pick even numbers. So we're going to plug these numbers in for x, or substitute them again, I should say. I'm sorry. So 1/2 times -4 is -2, plus 2 is 0. 1/2 times -2 is -1, plus 2 is 1, and so on. And then we're going to write those in coordinate points or ordered pairs. Okay, and then again I'm going to graph these here in just a second. So we substituted all these in, and we got our ordered pairs. You really only need 3. I like to do 3 or 4, just especially some that are negative, some that are positive, and include 0. Because when x is 0, that is our y-intercept. So I always choose 0 as one of my points so that I can see where it's going to hit the y-axis. So I'm going to list these again over here. And you can see the change each time in the y is plus 1. And in the x, the change every time is going up 2. So the change in y over the change in x, again, is 1 over 2. And we see that number written in front of the x. Again, we can see our y-intercept here is 0, 2. So when x is 0, that is our y-intercept, and that's where the 2 comes into the equation. So we're going to graph this. Okay, and so there are the points plotted on the graph. You can see they do make a straight line. Again, that is one of our checks because we know that these are linear. And we can see that the pattern here, once we graph it, the pattern here is up 1 over 2, and I'm making similar triangles. Again, up 1 over 2. And our slope is the change in y over change in x. So again, I'm choosing other points than the ones that are side by side. Picking the first and third point. So that's -4, 0, and 0, 2. We can see that the change there would be 2 over 4, which would reduce to 1/2. So you have the smallest triangle there, in the unit triangle, and then you can see that it goes up as similar triangles. It's always going to come back to that 1/2. So again, I'm going to choose another point, -2, 1, and 4, 4. The change in the y is 3, the change in the x is 6, and so 3 over 6 again reduces to 1/2. Now, down here, 0, 2 is the y-intercept. It's where it hits the y-axis. Therefore, that is where the 2 comes in the equation. So y equals 1/2 x plus 2, because it's going to be there on the y-intercept. So what I want you to do is look at this one, y equals 2/3 x minus 1. I want you to pause this video, and on your graph paper, I want you to try to do this one. Okay, so hopefully you've done that. Again, we're going to identify here that the y-m is 2/3. And the y-intercept is 0, -1. So now, instead of having to do all of those points, I don't have to do those. So if I know the y-intercept is at -1, then I can plot a point at -1, which is here. Let me circle this. So I went to -1, and then I counted up 2 and over 3. Up 2 and over 3. Up 2 and over 3. I got a little off there when I was trying to graph the straight line, but you can see that this goes up 2 and over 3. Now, we're going to talk about why this goes to the right or left in the next video. Right now, I'm just trying to get you to see the relationship between the equation, graphs, slope, and y-intercept. We'll talk about positive and negative lines in class the next day or in the next video. So now, again, I'm going to label these points here. And again, I'm going to check this by substituting these in. just going to show you that it works out the same. So in the first video, part of the video, I did these points first and then graphed. Here I did the graph and I'm checking with the points. So if I plug in 0 and I plug this in the equation, I get -1. If I plug in 3, I get +1. If I plug in 6, I get +3. And so these are the 3 points that we've graphed. Alright, so now I want you to go ahead and pause this video again. I've wrote the equation as y equals 3x minus 2, and it might help you to put the 1 underneath to graph this. Okay. So now, hopefully you got a graph that looks like this. Again, we're going to start at -2 on the y-axis because that's our y-intercept. And because this is 3 over 1, we're going to go up 3 over 1, up 3 over 1. Okay? Alright, so this is how to graph the equation with a slope and the y-intercept. Again, we're going to talk about this again, and we're going to talk about negative slopes in class, in part 2 of this.